Welcome back. I'd like to take the opportunity to summarize some of the major ideas that we have come across on the topic of intermolecular forces. Right now, we looked at four major type of compounds. One of them is nonpolar compounds. The second is polar compounds. The third is compounds containing hydrogen bonds, and the fourth is ionic compounds. Right now, what I have created here is a generalized sequence. Okay, this would work for most cases. Now, what I mean by nonpolar is less than, polar covalent is less than, hydrogen bonding less than, ionic is as you progress from nonpolar compounds all the way to ionic compounds, the effect on vapor pressure is significant. What do I mean by that? Let's say you take two beakers, each containing water, and in one you put a nonpolar compound, and in the other you put an ionic compound. The beaker contains the ionic compound would have the lowest vapor pressure. That means it would have the highest boiling point, right? So nonpolar compounds typically would have the least effect on the vapor pressure, and ionic compounds have the most effect on vapor pressure. What do I mean by most effect? That means it lowers the vapor pressure significantly, which means it leads to a higher boiling point. So nonpolar compounds have the least effect on vapor pressure, and ionic compounds have the most effect on vapor pressure, that it significantly lowers the vapor pressure. What does it mean? It means compounds that are ionic would have a higher boiling point compared to hydrogen bonding, and compounds that have hydrogen bonding have a higher boiling point compared to compounds that are polar covalent, and compounds that are polar covalent have a higher boiling point compared to compounds that are nonpolar, right? So let me summarize in general. So nonpolar compounds have the lowest boiling point, that is, they have a higher vapor pressure. And ionic compounds have the highest boiling point, that is, they have the lowest vapor pressure, all right? So it's easy to identify ionic compounds because you typically have a metal and a non-metal combination, and ionic compounds typically have ion dipole forces, right? I'm going from the bottom to the top. Compounds that contain direct nitrogen-hydrogen bond, oxygen-hydrogen bond, and fluorine-hydrogen bonds exhibit hydrogen bonding. Keep in mind, I have put the word direct. So if the hydrogen is not directly attached to the nitrogen, if it is somewhere in the molecule but is not directly attached to a nitrogen, oxygen, or fluorine, that compound cannot have hydrogen bonding. So there must be a direct attachment of hydrogen to nitrogen, right? And so if you ruled out your compound is not hydrogen bonding nor ionic, then how do we determine whether my compound is polar covalent or non-polar compound? We've learned it in Chem 170. So if a compound is polar covalent, if you take the electronegativity difference between two elements, it should be roughly between 0.6 and 1.6. And if that's the case, that compound is polar covalent. If, say, your electronegativity value is 0 to 0.5, then that compound is typically nonpolar, right? Say you have two compounds that are in the same category. Say you have two ionic compounds. Then how do we rank them? The one with the higher molar mass typically would result in lower vapor pressure, which means it'll have a higher boiling point. So let's look at this example. I've listed a bunch of compounds here. We know that NaCl and AlCl3 are ionic because they have a metal and a non-metal combination. But we have two ionic compounds. How do we know which one would have a higher boiling point? I just said if the molar mass is higher, that means it'll have a higher boiling point. So I've put the sequence here, and let me walk you through. Between NaCl and AlCl3, they're both ionic, but AlCl3 has a slightly higher molar mass, so it'll have the higher boiling point of the two. Now, there's only one compound containing hydrogen bonding, and that is methanol, which is CH3OH. You could see that the hydrogen is directly attached to the oxygen, right? It's not this hydrogen, but it's this hydrogen that's directly attached to oxygen, which means this can exhibit hydrogen bonding. So it's definitely higher than the remaining of the four compounds that are shown here. Now, how do I know these are not hydrogen bonding? Because there is no OH or FH or NH bonds in all these compounds. So none of them exhibit hydrogen bonding, neither are they ionic. But these three compounds, CCl4, CbR4, and Ci4, are all polar covalent bonds. That is, they have an electronegativity difference that's higher than 0.6 but less than 1.6. But we have three, so how do we sort them? You go to molar mass. Ci4 has the highest molar mass of the three, so it will have the highest boiling point, and then CbR4 and CCl4. And O2 is purely nonpolar because its electronegativity difference is 0. So it will have the lowest boiling point, right? So if you watch this video at least more than once, you would kind of get an overall view on what has been presented in the previous video. And this is a great way to summarize the entire concept on intermolecular forces. Now, there is another component to intermolecular forces, which is tying the idea of colligative properties and intermolecular forces through the heating curve and the phase diagram, which will be in the successive videos that will be presented as a slightly extended content of what is presented here, right? So here we have a summary of intermolecular forces, and I'll see you with heating curve and phase diagram, right? So stay tuned.